So there's one last force I want to talk about, and that is the force from a spring. And springs always try to return to a specific length or a specific position called the equilibrium position. And a force that does this, that always tries to return to a specific position, is called a restoring force. So for a spring, the variable is usually F subspring, and this force, F spring, is equal to negative k times x, which is also called Hooke's law. K in this case is a spring constant, and its units are newtons per meter, and a stiffer spring has a higher value for K. To figure out what value you plug in for X, let me show you some diagrams. First, I'll draw a spring that is simply sitting there loose, and it has a box attached to it in this case. And when the spring is loose like this, it's at its equilibrium position. That means that it's at position x equals 0. Then if you compress that spring, you're moving the position to the left. That means that the force is going to be to the right. And you can tell this from the equation because of the negative sign. If x is to the left, then the force must be to the right. So if you compress the spring, it exerts a force to the right. It's trying to push the box back into the equilibrium position. And if you stretch the spring, that means x is to the right, the force of the spring will be to the left, again, trying to push the box back to the equilibrium position.